It's a big day, my friends. Finally, now, we're going to be finishing our last Java syntax specific video. So if we look at all the things we've done, we just spent 4 weeks really grinding through a new programming language. And for those of you who already had Java experience, I hope you got something out of it. And for everybody else, I hope that you found that it's not so crazy to learn a new language. It's not like moving from English to Chinese or Arabic or whatever else. It's a closer thing, right? The basic underlying abstractions are very similar, and the vocabulary is not so large. And so that said, let's jump into perhaps the most exciting thing of all, object methods. So what are they? Well, recall that every class in Java is a hyponym of object. That is, a dog is an object, or a sled dog is an object. An array list, object. And so being a hyponym of object, they inherit all of these methods from this object class, which, by the way, is not abstract. You can do new object all day long. So what are the object methods that every object is guaranteed to have? toString, equals, getClass, hashcode, clone, finalize, notify, notify all, wait. Now we're not going to discuss these last ones in any detail in 61B. You can Google them and find out what they're all about. But we will use these top 4 somewhat often, and in fact we'll override this first, second, and fourth method here. So this lecture I'm only going to talk about these top 2 in detail, and we'll talk about hashcode in a later lecture when we talk about hash tables. So the first of these methods that we're going to discuss today is toString, and basically what it represents is the string representation of an object. So if you want to, when someone wants to print out your object, let's say, you want to provide the world with a nice string representation of, say, a dog, then you'll create a toString method. In this toString method, we see that we generate a string, which is a combination of the name, the mood of the dog, the breed of dog, the size, and so forth. And in that case, we then have a nice string that captures everything that is that dog. Now, there's nothing particularly interesting about a toString method, except that it's reliable. It's kind of like __stir or __ repr in Python. It's just something you can assume is there. And as we know, if you try and actually print out an object without a toString method, you just get some kind of a reference. It doesn't mean anything. But methods like printline, which expect objects, know that they can call the toString method because all objects have a toString method. Okay? The next one, and the last one here, will be equals. So as I mentioned in an offhand manner in previous lectures, the equals and dot equals methods, or sorry, the equal operator and the dot equals method, they behave differently. In particular, if we use equals in a naive way, we'll sometimes get results that don't work the way we expect. So here I have 2 arrays, x and y, and they are new int arrays, so they have their different instances. So these 64 bits in these 2 boxes are different. They're referring to different copies of the same information. So you and I might assume, okay, well, x and y, those seem pretty equal. So if I print this out, we expect maybe to get true. However, if you run this program, you actually get false. And that's because what equals does is compares the bits in the boxes. It says, are these 64 bits the same as these? And in this case, the answer is no. So the answer to this query is false. So if you want to actually test equality, well, with arrays, you'd usually use arrays.equal. Or if you have arrays of arrays, you'd use arrays.deepequals. And if you have classes, if you have instances of objects of some kind, we would use their .equals method. And if you want it to work properly, that means you have to write the .equals method because the default implementation is equals. And in that case, it wouldn't work if we wanted to compare, say, 2 dates, as we'll do in a moment, using the default method. So what do I mean by date? Well, this is a class I used very briefly in one of the earlier lectures, and it just represents a day of the year. Here we have the month, the day, the year. They're just 3 ints. There's a date method or a constructor, and then other stuff not shown. And so what I'm going to show you is what it's like to write a equals method so that we pass some tests. If you'd like, you can actually just try it on your own, and you don't have to actually watch this part of the video in order to do this. I think you can try and use your intuition. You can get pretty close. And this it'll be here in this in the lecture code repo, and I'll just jump right into that. So what I'm showing here now is this is the date class that we just had on the previous slide. And this is a test that's going to see if 2 dates are actually equals properly. So in JUnit, when you call assert equals, the way it works is it says, if I call d1a and I do .equals d1a, is the answer true? And if so, we'll be okay. Otherwise, we'll throw an error. So this right here, the way that the code actually works, the way the JUnit works, is it relies on the equals implementation of date, which, as we know, since it's not overridden, is just the equal operator. So this first date is just May 10th, 2010. This is another copy of the same date. Then we have D2. And so this test, assuming that we've written an equals method that works, we should pass it. Now if we run it, we'll see that we fail. And in fact, we fail on the second line. So D1A is considered D1A because they're equals. However, D1A and D1B are not equal. So let's try writing an equals method. So I might do public Boolean, in this case, equals, we'll do date O or D, and then we'll do some stuff. Now one issue that I want to bring up here before I even start writing code is that when you override a method, you should always put override. Okay, I just put it because one of the things you'll find is that maybe you screwed up in your method signature. Here I messed up. When I said override, I didn't actually override the method, which is supposed to be, if we go look at the method signature, must be equals object. Okay. So in other words, we need to change this to object, and that's incredibly important because if we didn't do that, then it's never going to call this method. Assert equals is going to continue to call the default method because dynamic method selection won't know how to find this. Okay. So by the way, make sure you always put override so you don't make silly mistakes like that. Okay, now what? Well, now I want to determine are two objects actually equal, or two dates equal? Well, first I'm going to say, we'll do UttaDate equals, cast this object, and then we'll simply say if, we'll go through each of the fields, if month is not equal to UttaDate.month, then we'll return false. If day is not equal to UttaDate.day, we'll return false. If year is not equal to UttaDate.year, we'll return false. And then finally, we'll return true. Now, we can be a little smarter about this, and not put it all on a bunch of different lines, but I'm just going to leave it this way because it reads easily. And so now, in theory, this method here should work. What's my warning here? If statement can be simplified, sure. All right, I know. All right, so now I'm going to run date equals test. And in this case, it still fails. In this case, on line 14. So it got through these all perfectly fine, but it failed on horse. And the issue is Java lang string cannot be cast to date. So our method, it's very important that it's capable of handling any object at all. And so in this case, the way we're going to do it is we'll say if, now we're going to rely on one of those other object methods. We're going to say if this.getClass equals o.getClass. Actually, we'll do not equals. So if they're not the same class, then we'll return false. Okay. So it's a little meta. When we run it, things work better. And now we get to line 15 where we crash. And in this case, the issue is null, right? In this case, we're trying to get null.getClass. And so the fix here is simply to say if o equals null, we'll return false immediately. Now all of this code here will work and pass our test. Okay, and it did. And so that's roughly what an equals method looks like. You have to do a null check, you have to do a class check, you have to do a cast, you have to check all the fields. Now this version I have on the slide is just a little cleaner than the version we had before, and it has one extra trick, which is it says if this is equal to x, return true. And this is just an optimization because if the actual pointers are equal, that is the references are the same, they have the same 64 bits, then there's no need to do all this work. So this is just a speed optimization, and the rest is for correctness. Okay. So I'll just mention earlier, I said there were some rules, finish something I mentioned earlier, which is there are some rules in Java for how equals is supposed to work. So it must be an equivalence relation as we call it in math. It needs to be reflexive. X must equal itself. It needs to be symmetric. X equals Y will be true if and only if Y also equals X, and it must also be transitive. If X equals Y and Y equals Z, then it must be the case that X equals Z. Now the compiler is not smart enough to check all these things, but all kinds of Java code out there assumes that it obeys all of these properties, and if your equals doesn't, then you can run into trouble, and we'll see a little funny example of this later when we talk about randomization. We must also, in addition to following these rules, we need to always take an object argument, so you cannot take a date argument as we saw. We need to be consistent, so if x equals y, then they must continue to be equal as long as neither changes. So it can't just be, say, a random number. That would just be a strange thing. If nothing in the two classes changes in the two instances, then they must continue to be equal. And it must also be never true for null. So it's always going to return false if you say x equals null. Okay, so that's everything we need to know about the core of Java. And as I've said, there's plenty of Java out there that we haven't covered, but this is enough. From here, we're going to expect you to find the syntax or the libraries that you need, though I ask on Project 2, you be very careful. Don't go using things like the Apache Commons library. Please use the built-in libraries. We have a list that are okay, and the reason there is we don't want to take away from the educational opportunity if you go out there and download, for example, a table.jar, right? Like, that's just silly. Then you defeated the whole point of the project, so don't do that. There will be extra optional syntax videos for those of you who want to learn about some more advanced Java syntax topics like type erasure, some more messy things about generics, and you'll see what those videos are if you want, but those are not required. You don't have to use them in your projects. They won't appear on exams, or if they do appear on exams, there'll be a full description of how it works from scratch, but I won't be mean and throw something in there that you won't know. And then from here now, we're going to launch into our big picture data structures and algorithms. The textbook that I'm a little behind on as of the time of recording this particular video, well, it ends now, and there's an optional textbook for the second half of the class for those of you who want readings for the data structures and algorithms part. So the lectures are going to kind of lighten the load a little bit while you're working on the big project 2, and then after that we'll pick up with some more aggressive, tricky ideas, but we're going to slow down the pace for the next 4 videos or so. If you're somebody just doing the class online, I encourage you to actually check out our Project 2 because I think it's a great experience for everybody. All the resources are available on the web except maybe the autograder, and I think it's something that is an important part of the course. Okay, see you in the next video.